Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. Welcome to the 7th International Conference on Electrical Control and Computer Engineering in 2023. My name is Wat Ismail bin Ibrahim from Faculty of Electrical and Electronic Engineering, Musti Malaysia Pahang, dan Sultan Abdullah. So today I would like to present part of our group research. The title is Maximum Power Point Tracking MPPT based particle swarm optimization PSO for hydrokinetic energy harnessing. Okay, for introduction, what is hydrokinetic energy harnessing? Okay, hydrokinetic energy harnessing is an electromechanical device that able to generate electricity by harnessing the kinetic energy of water flow. So as long as the river is flowing, so we can harness the electricity. So as can see on the figure here, so the basic concept of hydrokinetic energy harnessing is consists of the water turbine, and we have the generator here, then we have the controller. So this kind of the technology can be applied to the tidal, marine, river stream, and so on. Okay, why hydrokinetic technology? So compared to the conventional hydropower, hydrokinetic energy can be built up without reservoir. So it only involves a minimum civil work. Then this kind of technology only give a minimal impact to the environment. Okay. Now, so the most important is we can predict the flow of the water. This in terms of the concept and of operation, the hydrokinetic technology is similar to the wind turbine system. Okay, in terms of hardware, controller, and so on. Okay, even the output from the hydrokinetic technology is small. We can increase the capacity by array system. So we can increase the output power of this technology. Okay, for the problem statement, the fluctuation and also the variation of water velocity, especially the turbulent flow in a river is very challenging issue, especially when we want to design a control system that can able to harness the maximum output power. So we need to apply the MPPT algorithm. Then the conventional MPPT algorithm such as PNO MPPT algorithm produce the high oscillation output power. Okay, the system is stable at low water speed, but when the water speed is increased dramatically, this algorithm is unable to track the maximum power. The objective of the research is to propose the MPPT algorithm for maximum energy extraction in fluctuation of river velocity for the standalone hydrokinetic system. And second is to analyze and compare the performance of the PSO with a fixed step size PNO. So this is all the literature review on MPPT algorithm. Okay, we can see here. We just go through to this slide. Okay, for the methodology, this is the circuit topology for hydrokinetic energy harnessing under study. So the water turbine is directly coupled to the PMSG. PMSG is a permanent magnet synchronous generator. So the output from here from PMSG is a three-phase. Then it will convert to the DC output voltage using three-phase rectifier. Then here we have the boost converter. So the boost converter here is to perform the MPPT operation by controlling the MOSFET or IGBT here. IGBT switching the control the switching of IGBT on off lah. Okay, so the output voltage of the boost converter can be controlled by varying the duty cycle. Okay, by varying the duty cycle, the load seen by the generator PMST will be changing. Thus, the output voltage and rotational speed will be adjusted accordingly. Okay, PSO MPPT algorithm. PSO MPPT algorithm is pioneered by Kennedy and Everhart in 1995. Okay, the basic concept of the PSO algorithm is based on the social behavior of bird flocking and also fish schooling. Uh, so in this algorithm, the particle position is influenced by two crucial factors. Okay, first, its own best no position or the best. Then the second is the best solution discovered by all particle in the entire population, known as G best. Okay, during the exploration for the optimal solution, particles in the PSO algorithms explore a multidimensional search space guided by both the individual best no position and the collective best no position in all particles in the swarm. Through the iterative process, the particle position and velocities are updated according to equation 1 and 2. So this is equation 1 and this is the equation 2. So where W is the initial weight, okay, C1 and C2 is the acceleration coefficient, then R1 and R2 is the random value, reaching the range of 0 and 1. And the personal best position of particle is P best. Okay. And the best position of the particle swarm is G best. So we can summarize the PSO algorithm into 5 steps. Okay, as follow. Okay, step 1 is initialize the position and velocity of the particle randomly. Then step 2 is evaluate the objective function for each particle. Then step 3 is update the personal best P best and global best G best position based on the evaluation. Then step 4, update the velocities and position of each particle using the P best and G best information. Okay, lastly, step 5, repeat step 2 to 4 until the termination criteria is satisfied. Okay. So the function of the PSO in the MPPT algorithm is the duty cycle of the boost converter is represented by the particle position in the PSO. Then the velocity of the particle corresponded to the step size of the duty size. Then the objective function aim to maximize of the energy output of the converter. So this is the flowchart of the PSO MPPT algorithm. The optimization procedure comes with the initialize of the DC current reference value, then monitoring of the power generated. Then subsequently, the algorithm employs equation 1 and equation 2 to update the DC current reference and transmit a new value to the converter controller. Then this iterative process of generating new reference and converting the corresponding power continue until the conversion is satisfied. And then this criterion guarantees that all particles converge to the maximum power point. So we can have the duty cycle G best here, then the G best value can be sent to the controller in terms of the PWM. Okay, for the result and discussion, we have conducted two case study to test the performance of the PSO MPPT algorithm in terms of the tracking capability and also the output power. Okay, first case study is regarding to the rapidly changing of the water velocity speed. So we can see here the time 0 to 5. Okay, from 0 to 2.5 seconds, the water velocity is fixed at the 1 meter per second velocity. Then at 2.5 seconds, the water velocity is rapidly changing from 1.2 meter per second to 2.2 meter per second. So we can see here the PSO based MPPT algorithm produce the small oscillation compared to the conventional PNO. So we can see here if the large oscillation, okay, on the red is the PNO, the green is PSO. So PNO produce large oscillation, and of course it will reduce the output power and reduce the efficiency of the system. Okay, then for the case study 2, so we test the algorithm with a linearly speed of water velocity, okay, 1.2 until 2.2, and then we increase the speed linearly. And so we can see here the output power out of PSO and also PNO. Then this column is for the percentage efficiency. So the average PSO in terms of efficiency is 83.63 compared to the PNO MPPT, only 72.73% of efficiency. Okay, for the conclusion, in this paper, a successful application of the PSO-based MPPT algorithm is presented for controlling the duty cycle of the boost converter. Okay, this algorithm ensures that the extraction of the maximum available power from the water turbine without requiring prior knowledge of the system or sensor. So the proposed algorithm is characterized by its simplicity, independence, and flexibility. Okay, the simulation result demonstrate that dominance of the PSO MPPT over the PNO MPPT algorithm in terms of the accuracy and also efficiency, as it eliminate the oscillation around the peak power point and achieve an average of 83.63% efficiency. Okay, thank you to all. If you all have any question, kindly please email to me, wismail@ump.edu.my.